Okay, so we are at stop 2, and the name of the feature that we are looking at is the Hogsback Esker, or the Omimi Esker. And what we're actually looking at is that hill on the horizon there. So that is the Hogsback Esker. Does anybody recall from the lecture material that they had last week how an esker is formed? So eskers are formed when tunnels or channels within or on top of the ice get clogged up with sediment. So they get completely full of glacial material that's being transported through the glaciers, and then eventually the glaciers melt and retreat, and that pipe of sediment, or that tube of sediment, ends up sitting on the ground. So is it ice contact or is it a water contact feature?
A little bit of both.
A little bit of both, yes. So it is an ice contact water deposited feature. If we think about the kinds of particles that we might find in something that is being deposited by fast flowing water, do you think they're going to be rounded or are they going to be angular?
Rounded.
They're going to be rounded. As material gets transported, it gets tumbled around, and all of those angular corners get knocked off the particles as they travel through the tunnel. So what we're going to see when we actually look at the cross section of the esker at the next stop is a range of rounded material. Now, even during an ice age, there are seasonal variations, and there are going to be variations in flow rate. So in the spring and summer, water is going to flow faster. In the autumn and the winter, we're going to have lower flow, less turbulent flow. So if we have lower flow, do you think we're going to get coarser or finer particles deposited? Finer particles. So what we actually see in an esker is stratification of the particles depending on flow. So we end up with areas of coarse gravel, cobbles and boulders, and then we have layers of fine to coarse sand and fine to coarse gravel interbedded between them. So the lenses could be described as poorly graded or well sorted, and what we're going to see is stratified material inside of the esker. I'm going to show you a diagram of that in just a moment. Now, topographically speaking, although it's a little bit difficult to tell while we're looking at this feature, eskers in profile or in cross section look a little bit like a Toblerone. They are triangular shaped. The steepness of the sides and the roundness of the top is a little bit dependent on the composition of the esker. So something that has got more gravel is going to be steeper and pointier, and something that has got more sand, a lower angle of repose, is going to be more rounded on the top, and the sides are going to be less steep. So if you look at them in cross section, you're going to get a lovely triangular section made up of layers of well sorted, rounded water contact gravels and sands. And I have a picture here. So doesn't that make you think of chocolate? Doesn't it make you want to go and eat a Toblerone? You know, it's that kind of the afternoon, right? Okay, what do you think the silt and clay content in something that is formed by fairly rapidly moving water is going to be? It's going to be high or low? It's going to be fairly low. The turbulent water is going to move those silts and clays out of the way. It's going to deposit them much further away, and we're not going to have very many small particles inside. So if we think about an esker in terms of drainage, internally, is it going to be well drained or is it going to be poorly drained? It's going to be well drained. There's lots of interconnected pore space in an esker. So that has some implications for soil development. If if a gravelly or a sandy deposit is not really holding on to much water, are you going to get much in the way of soil formation on the top, do you think? No. So that's going to influence the type of vegetation that we would find on the top of an esker. What kind of vegetation do you think would thrive in that sort of environment?
Fine.
What's that?
Fine.
Pine trees, potentially, yep. In more general terms, what do you think we would be looking for? Essentially anything that is hardy and is going to thrive in an environment with very little water. So trees and plants that are drought tolerant, coniferous trees, things like, what have we got here? Things like cedars and sumacs, conifers, those sorts of plants are going to grow. You're not going to find much in the way of hardwoods up there because they need better soil conditions, they need a lot more water. The aerial extent of this particular esker is about 40 kilometers long, but eskers elsewhere in the world have been up to about 130. There's one in Nunavut that's about 135 kilometers long. These are very narrow, quite long features, and they're often sinuous. So they kind of move in a snake-like fashion across the landscape. They essentially look like rivers. They look like upside-down rivers if you were to look at them using some kind of remote sense technology, so satellite imagery or an aerial photograph or something like that.
Isn't that basically like what they are, kind of?
They essentially are. They're, you know, the sediment that's left behind after the flow of the river has disappeared. So they did form as rivers within the ice. Now, just as we got off the bus, there was a truck that drove past us heading in that direction. It's been pretty quiet so far, but we'll probably see some more. Where do you think those trucks are going? Up. So it's going to an aggregate pit. It's going to a gravel pit. And we'll see that as we get a bit further up the road. So eskers are a very valuable source of aggregates. We use aggregates every day, and the aggregate industry is a pretty significant contributor to GDP in Ontario, and this region is particularly valuable. So aggregates are used for everything: constructing schools, building roads, building houses, building hospitals. Pretty much everything, every piece of infrastructure that we have around us requires an aggregate input of some description. But aggregates are a non-renewable resource, and so there are some land use conflicts associated with the Omimi esker. What do you think a big pile of sand and gravel does to groundwater? What do you think it acts like? Acts like a giant filter. So eskers, and this esker particularly, is a groundwater recharge area. So it filters water, sends it to the aquifer, and there are people who live in Omimi who actually utilize that groundwater for drinking purposes, people who are not on municipal services. So if on one hand we're taking all of the gravel and the sand out over here, and on the other hand we want to use it, we want to keep it there for filtration purposes and to keep our groundwater recharge zone going, then there are conflicts. Some people want one thing, some people want another. So it's a pretty tricky situation between conserving and exploiting. A couple of other issues with land use on the Omimi esker. It's used for recreational purposes and conservation. So again, the aggregate industry is in conflict with that. But one of the other issues in this particular location is that some of the old abandoned pits were utilized as landfills. They're not anymore, but there are a number of landfills in abandoned pits within the Omimi esker. So what can you see as a potential problem using these kinds of materials as landfills? Yeah, the runoff. So what you're going to end up with is toxic leachate from the landfills that's percolating into the aquifers. And there have been a number of wells in the Omimi area that have been contaminated, and so the drinking water is no good anymore. toxic leachate from landfills has been known in various places around the world to cause illness and death. So not an ideal situation.